All right, for the second part of this example, I wanted to show you another way to solve this problem. Now, no voltage method is always going to work for solving these sorts of voltage and finding the gain. I would say sometimes, though, it's a little bit easier if you know that it's a very standard circuit or something that you're going to create at all the time. This difference amplifier circuit is very common. So the equation for this is pretty well known. If you look over here, this is something I've pulled from my slides. For this exact resistor layout, I want to be really clear. To apply this, we need to have this exact layout. Be really careful here. If you have this exact layout, you can use this equation. So what we need to do is then go collect all these bits here. So to find these, and I'm going to leave it in terms of VB and VA, but to find those two bits, come over here. Now, a lot of these things are going to be the same. We've got RA. It's a little bit squinto vision here, so I apologize. If you'll notice when we look at our value over here, we're saying RA and RB, RC and RD. So it's a little bit alphabetical, moving left to right and then down. So our first combination here, we'll grab those two values. Those are going to stay the same. So for part B, we're doing the same thing in the previous exercise, but the one difference that we're going to change is this 20 kilo ohm resistor is going to become 8. So we've got 10, 50, 4, and 8. So remember those values, 10, 50, 4, and 8. That's RA, RB, RC, and RD. Let's clean that up a little bit. We'll move this down. And then we're going to apply our values. So RA, 10, 50, 4, and 8. These are all going to be in terms of kilo ohms. Now you'll notice here that all of these are being multiplied and divided. We know when we get to this final answer that these are going to be gains, right? This is based on our gains. So what I want you to do when you do this is just ignore the K. If they're all kilo ohms, we can ignore it, right? We're multiplying by K, dividing by K, dividing by K. The kilo and the ohms will all cancel. We'll just get the gain, right? So V naught is going to look like VB. And then I'm going to multiply this. RD is up top, so I've got 8 times the sum of RA and RB. That's going to be 60. In the bottom, I've got RA, which is 10. I've got RC and RD. I'm going to add those two together. That's 12. And then I'm going to subtract RB divided by RA, 50 divided by 10, VA. Simplifying this a little bit, this becomes, well, this becomes 5, this becomes 4/5. Simplifying this, this just becomes 4 VB minus 5 VA. So I've come to my gain a little bit faster here, but the problem is this is one of those things that you're going to memorize once and then you're going to forget it for the rest of your life. It's a lot easier to be able to use that no voltage method for any type of difference amplifier. So now I've got this relationship though. Let me go back and check that I've got the right resistor values here. I've got 10, 50, 4, and remember this became an 8, right? We're repeating this. I now know what VB is. I want to find that same value. If I know that VB is 4, that's step 1. This is really setting up V naught, right? The second step here, let's switch colors. The second step is we're going to plug in VB. And remember, VB in this case was 4 volts, right? Going back, that's 4 volts. same as the last example. So plugging that in, we know that VB makes this looks like 16 minus 5 times VA. And I know that I want this to be between negative 10 volts, that's my negative VCC, and my positive 10 volts, that's my positive VCC. And then I will just simplify. So I'm going to subtract 16 from everything. This becomes negative 26. Is less than negative 5 times VA. Is less than negative 6. And then I can divide everything by negative 5. Remember, when I do that, my signs will change, so everything's going to get flip-flopped here. What do I mean by that? Let's go ahead and zoom back in. When I do that, these things are going to kind of invert each other. And this is going to move over here, so this becomes 26 divided by 5. That's going to become my max now. And this is going to move over to the other side. That's going to look like 6/5 over here. And in the middle, I've got VA. I can simplify this and say this is 1.2 volts. And this is 5.2 volts. So now I have the maximum and minimum value for VA. So you can see how we can change the resistor combinations here to change our gain and to also change our input, acceptable input values, right? That's kind of the goal here, is that we can manipulate those two things. So both of those cases, pretty similar. I would say the difference amplifier derivation thing is only going to help you if you have exactly that circuit. So be really careful about that. That's the biggest mistake I see with this.